Lesson 2.6 is titled Combinations of Functions and Composite Functions. In this lesson, we'll perform the 4 operations on multiple functions, adding, subtracting, multiplying, and dividing, and then we'll work with what's called composite functions. To work with arithmetic combinations of functions, you'll just have two different functions with overlapping domains. For all x's that are in common with both domains, you can do the sum, difference, product, and quotient. Sum would just be splitting up the definition into adding the two functions together. Difference is when you subtract. Product is when you multiply. And then quotient is when you divide. Recognizing that if you have x in the denominator, you have to restrict your domain. Otherwise, you're really just kind of combining like terms throughout the process. Okay, so let's give a couple a try. You're going to have two defined functions. In this case, we have f of x and g of x. Notice f of x equals 2x plus 1, and g of x equals x squared plus 2x minus 1. So part A says evaluate f plus g of x. Find f plus g of x, Then evaluate when x equals 3. The first thing we'll do is just simplify f plus g of x. By definition up above, that just expands into f of x plus g of x. And notice it's x in parentheses. We'll take each definition then and just substitute it in. F of x is equal to 2x plus 1. And g of x is x squared plus 2x minus 1. We really just combine like terms. That's all it is to add them together. Writing in order from biggest to smallest, we have an x squared. That cancels that term out. We have a positive 2x with another positive 2x, which would equal 4x. That cancels those two terms out. Then we have a positive 1 and a negative 1, and they just cancel. Therefore, f plus g, there we go. No, that's even worse. Sorry. F plus g of x simplifies to x squared plus 4x. That's our first answer. Then it says evaluate when x equals 3. That just means we'll plug in x equals 3, and then we'll evaluate. We would have 3 squared plus 4 times 3. 3 squared is 9. 4 times 3 is 12. 9 plus 12, 21. That's evaluating when x equals 3. The example on the right is subtraction, and it's the same process. Then evaluate when x equals 2. However, when we have subtraction, we have to keep in mind that order will matter when we try to simplify. So subtraction, the letter f, so function f is going to go first, f of x, and then we're going to subtract out whatever g of x is. When we substitute the values in place for f of x and g of x is 2x plus 1 minus g of x is x squared plus 2x minus 1. Since we're subtracting everything in that second function, we need to put it in parentheses. And then we'll distribute the negative in and combine like terms. Keep the 2x plus 1 for now, and then we'll have minus x squared minus 2x and then plus 1. Now that we've eliminated the parentheses, combine like terms, we have a negative x squared. That gets rid of that term. A positive 2x and a minus 2x, those actually cancel out as is. And then we have positive 1 and another positive 1, and that would give us plus 2. There's what f minus g of x would simplify to. I'm going to give myself just a little bit more space to finish this problem out just by sliding that screen in. Okay. Now to evaluate when x is 2. Just substitute it in. Watch out for that very first term. We would have negative 2 squared plus 2. And with order of operations, we would square the 2 first and get 4, but the negative then would make that negative 4 plus 2, and that gives us an output of negative 2. adding and subtracting functions together. For the next set of operations, let's let f of x be defined as x squared, and g of x is defined as x minus 3. Next, we're asked to find f times g of x. When f times g are together, you're literally just going to multiply the functions together. So it could be a distribute or it could be a FOIL. You're just going to do f of x times g of x. Now with just x on the inside, we'll take what f of x equals, which in this case is x squared, and then we're going to multiply it by g of x, which is x minus 3. So I'm going to put that in parentheses. When we multiply an outside number with something in parentheses, we're just going to distribute it in. X squared times x would be x cubed, minus x squared times 3, which would just become 3x squared. These aren't like terms, so that is the product f times g of x. That's all you do. It says then evaluate when x is 4. Just like the other two, you're going to substitute 4 in and simplify. In this case, we'll have 4 to the third power minus 3 times 4 squared. 4 to the third power is 64. 3 times 4 squared, well 4 squared is 16, times 3 is 48. 64 minus 48 would equal 16. That's the product when x equals 4. With one more operation division, let's let f of x equal x plus 3 this time, and g of x equal the square root of x. It says find f divided by g of x and state the domain. Then evaluate when x not only equals positive 9, but when it equals negative 9. To evaluate f divided by g of x, it's literally just division. We've done addition, we've done subtraction, multiplication, and now we'll do division. Like subtraction, order matters. So whatever letter's in the numerator, that function stays in the numerator. Whatever letter's in the denominator, that function goes in the denominator. If we write out it just as is, we get x plus 3 divided by the square root of x. Looking at this function, we know some things about the denominator. We know denominators can't equal 0, but square roots have to be positive, so it would have to be greater than 0. Therefore, if the square root of x has to be greater than 0 because it can't equal 0, that means x has to also be greater than 0. It would be positive, so the square root would work, and it wouldn't be 0, so then it wouldn't be undefined. This is your domain. As long as x has a value greater than 0, this division works. So then it says evaluate when x is 9, and then when x is negative 9. If we plug in positive 9 first, we would get 9 plus 3 in the numerator divided by the square root of 9 in the denominator. Well, 9 plus 3 is 12. The square root of 9 in the denominator is positive 3, and 12 divided by 3 is 4. That's what our output would equal. When x is negative 9, watch what happens. We have negative 9 plus 3 in the numerator, but then we run into trouble. We get the square root of negative 9 in the denominator. That's not a real solution, therefore this solution set is not possible. It doesn't fit the restriction in the domain. Finally, let's talk about the composition of functions. The composition of the function f with the function g, which is read f of g of x, it almost looks like a fog, like FOG with a cap or like an open circle, but it's really read f of g of x. Can also be written as f parentheses g of x parentheses. And the rule is to just work inside out. And this hopefully looks familiar to you from algebra class. The domain of f of g is the set of all x values in the domain such that g of x is in the domain of f. That's a lot of words, domain, in that definition, but what that means is the output of g of x, since we evaluate that first, becomes the input of f of x. That's a lot to write out, so hopefully you'll get that there, because I'm just already made a mistake. There we go. The input of f of x. There we go. Okay. All right, so let's try with some examples, and hopefully this will look familiar to you from last year. We have two different sets for f of x and g of x. F of x equals x plus 2, and g of x equals 4 minus x squared. In that first example, it's f open circle g and then 4 in parentheses, so this would be a composite function. This means f of g of 4. Whatever your x value is in the parentheses is what you're substituting into the function. To evaluate, you work inside out. And what I mean by that is you're going to start with the insidemost function, g of 4. Since the number 4 is in the parentheses, for g of x, we're just going to plug in 4 where we see x and then simplify. So we get 4 minus 4 squared. And 4 minus 16 is negative 12. Now that output becomes the input for f of x, and that's your step 2. F of x is on the outside, so we evaluate that function last. Whatever answer we got for g, we have to plug that in for f of x. Now f of x was just x plus 2. If we plug in negative 12 and then we add 2 to it, our final result is negative 10. That means f of g of 4 is equal to negative 10. Let's try just one more, and then we'll finish the rest tomorrow in class. G of f of negative 2. Now notice the order of the letters is switched, which means we'll evaluate them in the opposite order for that result. G of f of 2 would be the same as g of f of negative 2. Now to process this, we'll start with the inside. We'll evaluate f of negative 2 first. So in the f of x function, negative 2 plus 2 is 0. Now that output becomes the input for the g of x function, because that's on the outside, g of 0. Now g of x was 4 minus x squared, meaning if we do 4 minus 0 squared, that would just be 4 minus 0, which is 4. G of f of negative 2 has an output of 4. We'll finish the rest of these in class.